Welcome to lesson 7, unit rate as a constant of proportionality. Let's go ahead and start with example 1. National forest deer population in danger. It says the wild conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of forest. Do conservationists need to be worried? Why does it matter if the deer population is not constant in a certain area of the national forest? You got to use some background knowledge and kind of think about what happens when something is, let's say, overpopulated, land is overpopulated. What suffers? We have food supply, overpopulation, and then damage to the land. These are all things to consider. What is the population density of deer per square mile? So deer per, keyword per, from that statement, we need to find the constant of proportionality. In other words, the unit rate. Let's put that in parentheses. Find the COP, aka unit rate, for each population. So I like to set up a table to organize the information for you guys. So we have our square miles in this column. Oh, this is a bit too big. I'm going to zoom in a little bit more. Okay, so square miles. I'm going to call that my X. Number of deer. I'll call that Y. And Y, how do we find the unit rate? Y divided by X. Okay, so for 16 square miles, according to the word problems, there's 144 deer. So we should do 144 divided by 16, which equals 9. Or you also remember the unit rate is Y divided by X. As this form. And then we have 13, 117 divided by 3 also equals 9. I can't exactly fit all my stuff in the space that I've designated, so I'm going to create another table. (24) 216, and then 216 divided by 24 is going to equal 9. As you can see, they were all the same. So the unit rate of deer per 1 square mile is 9. That makes our constant of proportionality also K equals 9. Now, what does the constant of proportionality mean in this problem? In other words, what does it mean particularly to this problem? Well, just take your unit rate and plug it in. There are 9 deer for every 1 square mile. Pretty much describe the unit rate. Use the unit rate of deer per square mile, or Y divided by X, to determine how many deer there are for 207 square miles. So if you recall the formula Y equals KX, the equation, we can use this equation to determine how many there are for 207 square miles. And according to our table, Y is the number of deer, and X is the square miles. And we've been given 207 square miles. So we want to set up our problem as y equals, and k equals 9 as well, 9 times 207. So that tells us that y equals 1,863. And therefore, there are 1,863 deer for every 207 square miles. Use the unit rate to determine the number of square miles in which you would find 486 deers. So once again, I'm going to start with my equations. Y equals kx. Okay, if you recall, remember y is deer and x represents the miles, and k is a constant proportionality. So our number of deer, according to the problem, is 486 deer. K is 9, and we're trying to solve for x, the number of miles. To solve for x, ask yourself, what times 9 is 486? So we want to go ahead and work backwards. We're going to divide by 9 on both sides. And 486 divided by 9 is equal to 54. So the number of square miles in which you would find 486 deers is 54. Okay, let's move on to our next page. All right, we talked about this for some brief time in other lessons, but a variable, remember, is a symbol such as a letter. These letters can be X, Y, A, B, C. It doesn't matter. It's any letter in our alphabet. But typically, when we're talking with constant proportionality, you see the letters X, Y, and K, where K is the constant of proportionality, okay? And X and Y represent all the pairs of the numbers. Now, sometimes X and Y change. If I use, let's say, the formula distance equals rate times time, then I'm going to be dealing with T and D. In other words, we're just using the formula D equals RT. Now, you need what? Example 2. Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students. That's a lot of cookies. Unfortunately, he needs the cookies the very next day. Brandon and his mother determined that they can fit 36 cookies on 2 cookie sheets. Is the number of cookies proportional to the number of cookie sheets used in baking? Create a table that shows data for the number of sheets needed for the total number of cookies baked. Okay, so I'm going to create a table. So, number of cookie sheets. Okay, so cookies baked. And then, last but not least, our y divided by our x, right? Okay, so according to our problem, Brandon and his mother determined they can fit 36 cookies on 2 baking sheets. So with 2 sheets, I can make 36 cookies. So that means per sheet, 36 divided by 2, I can get 18 cookies on 1 baking sheet. All right, so if I use 4 cooking sheets, my number is going to double, add another 36. You're going to still see that you're going to have 18 per cooking sheet. And then if I go to 10, well, obviously, so far we can see there's 18 cookies per sheet, so 18 times 10 is 180. And then, once again, my unit rate. And last but not least, let's say 16, because I want to try one more. I'm going to get 288 cookies. And I can see I'm going to get 18 cookies per sheet still. So the unit rate of y divided by x is 18. And once again, our constant of proportionality is y equals, I'm sorry, not y, k equals 18. Now we're going to explain the meaning of the constant of proportionality in this problem. Just like our previous problem, restate your unit rate. There are 18 cookies per sheet. It takes 2 hours to bake 8 sheets of cookies. 8 sheets of cookies, I'm sorry. If Brandon and his mother began baking at 4:00 p.m., when will they finish baking the cookies? Well, we first need to figure out how many cookies we want to make. So there's 96 students. They want to make 3 cookies per student. And it's going to give me 288 cookies. Okay? And I already know I can get how many cookies per sheet? 288. I'm sorry, 18. 288 divided by 18, 288 cookies, is going to give me 16 sheets of cookies. And let's go back to our problem. We already know 2 hours to bake 8 sheets of cookies. Then that means in order to make 16 sheets of cookies, I'm just multiplying by 2. My time is just doubling. It's going to take me 4 hours. So, when they finish the baking the cookies, they will finish baking cookies at 8:00 at night. Since it will take 4 hours to bake 16 sheets, they will finish at 8. Okay, I'm going to pause the video here, and example 3 will be in a separate video. Thank you.